With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hi everyone, so we are given with a question which says an ideal ammeter is connected in the circuit as shown in the diagram. What will be the reading of ammeter in SI unit? So we need to calculate the reading of this ammeter. An ammeter is been given to be as ideal. So we know for an ideal ammeter, resistance value of ammeter is 0. Alright, we consider it to be as 0. So this circuit can be redrawn in this fashion. Just to understand the concept of jumping of a jumping connection. This type of connection is known as jump connection. It is very much necessary to understand how to resolve this component for in case of a much complicated circuit. That's why we have drawn it over here as in this fashion. So this type of jump can be resolved in this way. Alright, so now we can give the potentials to the every point. So here it is 10 volt, so it is 10 volt over here, and here it is 0 volt. So this connection, this point will have a 0 volt, 0 potential. This point also will have a 0 volt potential. This point also will have a 0 volt potential, and here we can see this point will have a 10 volt potential. And since we have considered the ammeter resistance to be a 0, so this point will also have a same volt, that is 10 volt. Alright, so these all things has been done, that is we have allotted the potential to every point. Now we can calculate the value of current. Let's assume that the current which is flowing through this branch is I1, current flowing through this branch is I2, and current flowing through this branch is I3, and the total current which is flowing through ammeter is I. Alright, so now we can just apply the Ohm's law and we can calculate the value of I1, I2 and I3. So in this section we can say, therefore the value of I3 will be nothing but potential difference, that is 10 minus 0 divided by 2, and that comes out to be 5 ampere. So this is the value of I3 we have got. Similar way we can calculate the value of I2. I2 can be straight away written as 10 minus 0 by 2, and that again comes out to be 5 ampere. And finally we can check the value of I3, I1. So for I1 we can say, here it is 10, here it is here it is a drop, so we can say 10 minus of 6 divided by 2, and that comes out to be 2 ampere. Alright, so this is the values of current we have calculated. So now as we can see this point, that is which is having a 10 volt potential. So at this point the current coming is I, and the current leaving this point is I1 and I2. So applying KCL at this point, we can write, applying current Kirchhoff current law, or we can say junction law, we can say I will be equals to I1 plus I2. This is the law, that is current coming towards the junction is equals to current leaving the junction. Therefore the value of I can be written as I1, we have calculated it as 2, and I2 as 5. So the total current through ammeter will be 7 ampere. Alright, so this is the reading of ammeter, and this matches with option B. So I hope you have understood the concept, and thank you for watching.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.